take a look at if we can determine whether or not a function is continuous at a particular point. So up here we have 5 functions, and we're concerned with whether or not these functions are continuous at the value x is equal to negative pi over 2. All right, so let's start with our first function, which is y equals e to the x. Okay, you studied e to the x as a function in pre-calculus. You looked at its graph, you looked at its particular values, and we know from the graph of e to the x that it follows that curve very briefly right there. Okay, now I just graphed that entire curve of e to the x, and my marker never left the board. It turns out that e to the x, because I just did that, is continuous for all values. If it's continuous at all values, it means it's definitely continuous at negative pi over 2. And lo and behold, we have no issues at x equals negative pi over 2. So yes, the function e to the x is continuous at x equals negative pi over 2. How about the natural log of x? All right, the natural log of x you also studied in pre-calculus. That is the inverse function of e to the x, which means it's reflected over the y equals x line, which means its curve looks like that. Now I just drew that entire curve on its domain, and I had no issues as well. So it seems like the function is continuous. Okay, but it's continuous on its domain. What's the domain of the natural log of x? You learned that in pre-calculus as well. The domain of the natural log of x, as we can see clearly from this picture, is that x must be positive. The function does not exist for x having negative values, and negative pi over 2 is over here. There's no function there. The function doesn't exist there. That's the first requirement for continuity, is that f of a must exist. All right, well, the function natural log of x does not exist when x is equal to negative pi over 2. So if it doesn't exist, it cannot be continuous there. So no, it's not continuous. How about at tangent x? Another wonderful function that you learned in pre-calculus. And if we look at the graph of tangent, if you recall, it's a graph which repeats itself over and over and over. And it looks very briefly like that. Okay, so as I drew each of those curves, right, well, tangent is continuous this entire point value, that entire interval. I just drew that interval, and I didn't pick my marker up off the board. But to get from this interval to this interval, now my marker does have to come off the board. So tangent has a bunch of discontinuities. All right, it's continuous for particular intervals, and it has various points of contention, various discontinuities. The question is, where does negative pi over 2 fall? Well, it turns out the negative pi over 2 falls right there, where we change from this curve, and I take my marker off the board to that curve. So we've got an issue there. And lo and behold, if you take your graphing calculator, or any calculator, you do the tangent of negative pi over 2, you're going to get an undefined answer on the calculator. Tangent is not continuous at x equals negative pi over 2. What about another trig function? What about the sine of x? You learned about that function in pre-calculus as well. Learned a lot of things in pre-calculus, right? The graph of sine is that wonderful wave function, right? And that wave function just goes on and on and on and on, okay? It never ends. And I never have to take my marker off the board in order for me to graph that. So sine x is like e to the x. It's continuous for all real numbers. There's no issues. There's no way that we can divide by 0 like we could for tangent. There's no issues in the domain where the function doesn't exist, like there was for natural log. There are no issues at all, and therefore, yes, the function sine x is continuous at negative pi over 2. In fact, it's the bottom of that hill right there, or the bottom of that valley, I should say. I just graphed right through there, had no issues with my marker. The function is continuous at x equals negative pi over 2. Okay, and last but not least, we have x minus 6 over x plus pi over 2. Okay, so we have a rational function right here. We have to look and see what value of x causes us to divide by 0, because we know that our function will not exist where we divide by 0. And look at that. If we plug negative pi over 2 into our denominator right there, we're going to get 0. We can't do that. So this last function is not continuous at x equals negative pi over 2. So if I plug that x value into my denominator, I'm going to get 0, and I can't divide by 0. The function doesn't exist there. Again, the first requirement of continuity fails.